Hello everybody, welcome to the Homework Helper for section 3.7. Let's go ahead and get started with this. The very first section in the ready says determine the domain and range and whether the relation is a function or not. Determine if each set of ordered pairs is a function or not, and then state the domain and range. So to do this, we're given a set of numbers, and we have little squiggly brackets here, and that tells us that we have a set of points. So these are our set of points. And so to figure out what our domain, don't forget that we have our little function here, right? We have our function like this. So we have a domain goes in. This is our x values that go in. And our range comes out. This is our f of x after the function's worked on it. So when I look at my domain, what I'm looking at is I'm looking at the set of values that make up my x. So -7 is in my domain, 3, 8, -6, and -2. So when I write my domain, I want to write those numbers. Now I want to write them from lowest to highest. So I'll do -7 first, then I'll do -6, then I'll do -2, then I'll do 3, and then I'll do 8. And those are the numbers in my domain. I will then do numbers in my range. These will be my outputs, my f of x, my y's. So 2, 5, 4, 5, and 3. And again, I want to put these from lowest to highest. So 2, 3, I have 2 5s, so I'll just write it once. Oops, and I missed 4 here, so there should be 4, 5, and that'll be it. Okay. So that's my domain, that's my range. Is this a function? Well, would this pass the vertical line test? Yeah, because nowhere on the same x do I have 2 y's. So yes, this is a function. Let's do the next one. Okay, same deal. Let's look at our domains. 9, 0, 4, 5, 2, 0, 3. Okay, so I want to put these from lowest to highest. So the domain is the set of numbers 0. Oh, you see I have 2 zeros here? Oh, look at this. So I have 0, 4, and I have 0, -3. So would that pass the vertical line test? Well, if it was at 0 and I had a dot at 4 and a dot at -3, that would fail the vertical line test. So I know it's not a function. But I can still figure out the domain and range. 0, 2, 3, 4, 5, and 9. And then my range would be my y values. So what's the lowest? -3, -1. I'm just making these dashes so I know that I've crossed them off. 0, 2, 3, 4, and 7. Okay, that's it. That's what I'm asking you to do for these. All right, for next ones, we've got to determine the domain and range of the given function. So it's giving us this. We have to figure out what our possible x values are, what our possible y values are. So domain, all possible x values. The lowest value is right here at 1. So it's going to be 1. It's a solid dot, so I'll make a bracket. And I see that the arrowhead as we go to the right goes on forever. So it's going to be a positive infinity with a parentheses. Range, the lowest y value is a 0. And it's a dot, so I can put a bracket. And then this will continue, the arrowhead tells me it's going to continue on going up, so that will also be to infinity with a parentheses. Let me do this next one. Domain, so I see that I go from, what is this, -5 to 0, and then it stops. So from -5 to 0, right, from -5 to 0 is I'm in my domain. Then there's a break, and it picks up again at 2, and then it stops again at 8. So from -5 to 0 and 2 to 8 are values that can go into my x. Those are my domains. And then my range, I look at my lowest value as -3. And then that goes on until, see right here, even though it splits on our domain, look at it from our range point of view. As it goes up, it's constantly touching. It's constantly touching. So our range goes from -3 to 3 with no breaks, with no gaps. So that will stay that way. Cool. All right. Let's go to the next one. Set. All right. Determine the domain and range and determine whether or not it's a function. So the distance a person is from the ground related to the time they ride a Ferris wheel. So what would that look like? Okay, so this is time, this is distance. Okay, you're on the Ferris wheel, you get on the ground, the Ferris wheel goes up, you're up in the air, you're at the top of the Ferris wheel, you start to come down, and then you're right back at where you got on, and then you go up again in the Ferris wheel, all right? Then you go down, okay? So it says determine the domain and range. So time's our domain, okay? Time is the domain. Height, the distance a person is from the ground, the distance. This is our range. And then is this a function? Yes, it's a function. Okay. So just think about each of these. Think about which of these values will be our domain, which of them will be the range. What's our input? You know, how long you're on the Ferris wheel determines how far off the ground you are. Not how far off the ground doesn't determine how long you've been on the Ferris wheel, because here's the same height, it's two different times. All right. Finally, we have this very complicated determine the feature of the function. It says describe the function in the graph. So where is it decreasing and or increasing? So let's look at decreasing first. Okay, decreasing from -5 to 3. It's decreasing this entire time. Even though it makes this bend here, it's decreasing, but then it's decreasing at a different rate. So it's decreasing the whole way. So from -5 to 3, it's decreasing. And then that's it. And then it's increasing as we go from 3 to 15. Okay, because here it starts to go up. All right. Identify the min and or max. The minimum appears to be at -3. The max appears to be at 8. And then the domain and range. Domain is all possible x values, so from -5 to 15. And then the range is all possible y values, so from 3 to 8. That's it. Pretty easy. So make sure you're aware of your domain and range. When it's talking about intervals of increasing and decreasing, we care about the domain on which it's increasing or decreasing. Pretty much the only time we care about our range is when it specifically asks for our range. But any other intervals we're talking about our domain. All right, everybody. Good luck with this, and see you next time.